I'm just going to be talking about, I'll give a small recap on what Hadoop MapReduce next is, if anyone doesn't know. And I'll give a brief overview of what we've been doing and what we need to do, what we intend to do next. So how many of you have read Arun's blog on MapReduce next or heard his talk? Not many? Okay, so for you it's going to be a little boring in the next few slides because I'm going to give a recap of what Hadoop MapReduce next looks like. So just a brief intro about what I do. So I mostly work on Zookeeper and Hadoop, and since Zookeeper is all perfect right now, so I decided to work on MapReduce next. So here's what. We introduced a lot of concepts last time when Arun talked about MapReduce next, and I'll just give a recap on what these concepts are so that people understand what the demo is about. So we have a concept of an application. So an application is a job submitted to the framework. So it can be a MapReduce job. So our target is just in the first few months to work on MapReduce, and later we'll see we'll see if others want to work on MPI or some other kind of jobs. And the other main basic concept is a concept of container. So a container is a basic unit of allocation. So let's say a container A can be a 2 GB resource and 1 CPU. So what this means is an application can ask for a container, and this is the basic unit that the resource manager will allocate. So it can be 2 GB and 1 CPU, or 1 GB no CPU. So it's very dynamic. So we replaced the fixed MapReduce lots model with the container model. And the next concept is the resource manager. It's a master daemon. Mostly like the job tracker, which tracks all the other daemons. And it does global resource scheduling. So it decides on which containers to allocate to which applications. And it has hierarchical queues. And we have node manager, which is a per machine daemon. And it manages the life cycle of containers. And it also does resource monitoring for these containers. Exactly like what the task tracker does right now. And then we have application master. And then we have application master, which is a per application daemon. Not really daemon, but the process. And it manages task scheduling and task execution. So, for example, you can consider the MapReduce application master, which is responsible for running the map tasks and the reduce tasks. So, and the application master lifecycle is managed by the resource manager. So, all this will become clear in the next picture. So, I just copied this picture from Arun's slides. So I don't know if it's yellow or what color it is. So the yellow things mean nodes, and the blue, the resource manager, node managers, these are all daemons. So there is only one resource manager, one master, and there are node managers, which are the compute daemons, which are running on compute nodes. And what happens is, let's say a client submits an application, a job to the resource manager. The resource manager will then say, okay, I have some jobs submitted to me, and then it will say, okay, I need to allocate one container to run the application master for this job. So what it will do is it will find a container, in this case, the topmost, a container of the topmost node manager to run the application master. So it will launch this application master, and this application master, when it comes up, is responsible for running all the tasks it has to run. So in case of MapReduce, this MapReduce application master will come up and say, okay, how many reduces do I need to run? So let's say it has 5 maps and 5 reducers. So it will talk to the resource manager and say, okay, I need resources to run these, I need containers to run these 5 maps and 5 reducers. It's more generalized, that's what I'm just giving you an overview. So, and then it gets those containers, those resources from the resource manager, and then launches these tasks and make sure these tasks are run on the cluster. So this is another client submitting the job to the resource manager, and the resource manager actually allocates another application master for it, and this application master will come up and then ask for containers, and then we launch these containers to complete the tasks that this job has. So the current status of MapReduce Next that we've open source, I think everybody should be aware of that. So this is available on SVN branch MR279. Our target is 0.23 release. And the design architecture has been posted on, there's a blog post that Arun have made. You can read through it to actually go into the details of what the design looks like. And the MapReduce APIs for 0.20 and 0.22 are supported, so there is no user-facing change at all. So where are we with this? So we are almost feature complete. We intend to be feature complete in the next 2 weeks. And we've run sort on 500 nodes, which is a good thing. And it works. And we are in the process of running integration testing with Pig and Uzi. So this is where we are. And I'll just give a brief demo. If you have any questions, please feel free to ask me while I try to get this working. Okay, so what I'm going to do is I'm going to bring up SGFS cluster. This is just running on my laptop so that I don't have no issues with the network. So I'm just going to run a name node and a data node, and then run the yarn tables, and then run Java. So this is running the name node. Running the data node. The name node and data node are up. So now I'm going to start the resource manager and the node manager. But before that, I'll just point out some configs that are necessary. So just take a note of the first property. So what we do is we made the job client pluggable, so that you can submit jobs to the job tracker, or you can submit job to the new MR next generation resource manager and the node manager. Okay, so this is the property that you need to set to be able to submit jobs to the new resource manager. So I'm starting the resource manager. This is the web UI. So you can see that since there's only one node manager, so this is showing that only one node manager reported, and it's healthy, and when its last health update was, which is probably not very readable right now, but hopefully we will make it readable soon. And we have a separate web UI for the scheduler. So this is the capacity scheduler we are running. So it will show you all the queues that are there, and if you hover around on the queues, it shows you what's used, and it shows you what the capacity is and what the max capacity is. And let's try submitting a job. So actually, let me just clear this so that you can see. Yeah, so the command line actually looks a little big right now because we have to add a couple of parameters to make it so that it is able to run these jobs. So these should go away. So one of the parameters is actually job.user.name, which will go away. So it's just probably it's a bug we need to fix. And there's another parameter that you'll see is the -libjars, which is different than what just to run the job, because we have this job client jar, the new job client jar, which has all the classes to be able to submit to the resource manager. That's why we need to use -libjars. So other than that, the command line exactly looks the same that you've been using to submit jobs. So it's just been to jar, random writer, and just the directory with the output you throw. So it's exactly the same except for few parameters. So this I submitted the job. Hopefully it will run. Let's see. Okay. So this state will show you various states of the application master, what's happening in it right now. Laptop seems too slow. Okay, so it's running right now. So what you can do is you can go to the application master web UI and see the job running. So here, if you go deep into the job, you will see the maps and the reducers. So the web UI is very nice. So what you can do is you can sort the progress, you can sort with the state, you can sort with the start time and finish time, and also you can search if you want to search for a specific task, let's say underscore R. There's no reducers in this, sorry, but that's how you can search for the task that you're looking for. So that's, yeah. So the job is done, and it will show you exactly the counters and every other information that used to show earlier. And so it's exactly the same that how it used to work on the user facing side. So that's that.
So you showed just one extra parameter, meaning Hadoop could have a lot of parameters, it's overwhelming sometimes. So this is adding how much more complexity for the
Also, the question is that you added one more parameter, and already there are too many parameters in Hadoop and it's adding more complexity. So the parameters right now is just that we need to fix them. So we're not even going to add one more parameter. We're just going to get rid of it as soon as we fix it.
No, that's okay, meaning, but to run this whole thing, are we going to have additional 10 unique parameters?
Oh, so the question is that for running this thing, are we going to have additional parameters? So there's not going to be, so the parameters that you're going to be using for the resource manager and node manager will replace the parameters that you had for the job tracker and the node manager. So in the sense that it will be the same amount of parameters that you need to give. Okay. Yes?
Why did you choose the next gen to be this enhancement why didn't we add the GPU abstraction to the MapReduce? But MapReduce can be applied to GPU, and then we can whether abstracting with OpenCL or whether with OpenGL, and then we can have these also cooking with the data as well.
Okay, so
there was work at UC Irvine, and a seminal paper was published in that regard. And it was in C++, and I was expecting the natural evolution of things to go that way.
Okay, so I don't have any background on what this research is about, so I probably might not be able to answer it. But we can talk later after we're done.
The question is about GPUs. Can you repeat the question?
The question was why the next generation of MapReduce was going this way. What was the problem that we were trying to solve? I was expecting that the next gen would work with abstracting the GPU, the graphics processing capabilities of the machine, because then we can run jobs with utilizing the GPU as well as the CPU cores. Now, there was a seminal work at UC Irvine, a work that was very successfully, they managed to create a MapReduce abstraction with the GPU, but that was done with C++, and I was expecting that we would be going this route to add this computational power that is still wasted so far, because OpenCL is still not a mainstream and not easy to use. Thank you.
Hi, this is Arun. I work with Mahadev on MapReduce. So the question about GPUs, it's an interesting thing we've considered in the past, but most of the mainstream Hadoop installations won't have 40,000 machines with GPUs on. We have very little GPU power, and hence as a community, it's not something we're focused on, but long term, yes. I mean, the architecture we have with next-gen MapReduce, we can definitely abstract any of the resources, whether it's CPU or GPU or RAM or disk or network bandwidth or whatever. We can abstract it as a resource, and then we can do scheduling based on different kinds of resources we want. But it's not something we've focused on for this resource.
So actually, yes, the MapReduce Next would actually help you in doing all this GPU and all that to do a GPU-based scheduling and GPU-based use those resources in the framework. It will actually help you on that.
With this generation or future? How can this one help? The resources, can I allocate the resources?
Yes, you can allocate the resource. You'll have to.
You need to do more work
to
do it, but it's very feasible for us to abstract GPU as a resource and do scheduling.
Yes.
Is there an application master for each job?
Yes, right now there's an application master for each job. So the question is there an application master for each job? The answer is yes, there's an application master for each job right now. But as we move later, we think that each of this, a single application master can actually run a diet of jobs and be much more useful.
So then the scheduler is in the resource manager?
So the question is the scheduler in the resource manager? Yes, the scheduler is actually in the resource manager. Any other questions?
MapReduce is a parallel computing design pattern, right? And it was invented by Murray Cole in 1989 at the University of Glasgow, UK, and it's not by Google. Now, the next evolution of map for Hadoop, I was expecting the seminal work with the parallel computing design patterns by Murray, because I doubt this is a universal computing machine, right? So is there in the pipeline any plans to introduce new parallel design patterns from algorithmic skeletons in Hadoop?
So the question is, do we support other paradigms other than MapReduce? Right?
Yes.
The answer is this framework, we allow two levels of scheduling. One is the global resource manager, who's only arbitrating resource needs. But there's a per application master who can be either a MapReduce application master or an MPI master or any other framework you want. So the contract you will get is to be able to get resources, and how you use the resources up to the application master. So you can write an MPI application master. It takes resources from the resource manager and runs MPI application. So that's how we plan to support other paradigms.
That's it? No more questions? We're talking about the next generation of MapReduce and no more questions here? Come on, you gotta still have questions. No?
It's fine, Avik.
You guys say so. Wrapping up.
It's scheduled for 0.22. Why it's now become 0.23?
So no, 0.22 is different release. So we are expecting to get this done in 0.23.
A lot of database companies, Astrodata, Greenplum, other guys, are integrating MapReduce with database, making hybrids. You guys planning on doing that?
You guys mind?
Or is Hive and HBase yet?
So the question is that we should integrate well with databases? Are we planning to?
In the way that Greenplum and Astrodata are.
Oh, so
Really hybrid.
Like a hybrid? So I don't know. It's up to the community where they decide on where this goes. And we
Who makes those decisions? It's not you. It's someone else here that makes those decisions.
Our boss makes the decision.
Where's he? Is he here?
Not really. The politically correct answer is
He's not here?
No, the community makes that decision.
Yeah,
So when is he going to come talk? In other words, when do we get to ask him, the decision maker?
So the answer is that Apache, Hadoop is Apache some foundation project and it's volunteer.
I understand.
And it depends on where the volunteers are going to invest in their time. So,
Okay.
Thank you.
I was wondering if there are any updates or changes to HDFS related to this new next generation of
we don't have to make any changes to HDFS. HDFS itself, the next release will have major features like federation and so on. So we plan to integrate and work with. The big thing we do need from HDFS for this is a pen. We use a pen in a couple of interesting ways. But other than that, we don't have any other dependencies.